In this episode, we're going to look at how to investigate the TCP and OSI models in action. I'll show you how to do it and have a discussion of the concepts on the way. This activity is intended to provide a foundation for understanding the TCP/IP protocol suite and the relationship to the OSI model. Simulation mode allows us to view the data contents being sent across the network at each layer. As data moves through the network, it is broken into smaller pieces and identified so that the pieces can be put back together when they arrive at the destination. Each piece is assigned a name or a protocol data unit and associated with a specific layer of the TCP and OSI model. Packet Tracer simulation mode enables you to view each of these layers and associated PDUs. We're going to look at some steps that lead the user through the process of requesting a web page from a web server by using a web browser application available on the client PC. Even though much of the information displayed will be discussed in more detail later, this is an opportunity to explore the functionality of Packet Tracer and to be able to visualize the encapsulation process. We'll be discussing how to examine HTTP web traffic, displaying elements of the TCP/IP protocol suite. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on practical configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Investigate the TCP, IP, and OSI models in action. Okay, here we have the Packet Tracer Lab open. On the left side, I have my working area where I can go and configure my devices and do all the inspection that we're going to have to do. On the right side, I have the Word document of the lab opened up. The reason I have the Word document is so I can answer the questions. We're going to examine some HTTP traffic, and then we're going to display some elements of the TCP/IP suite so we can learn a little bit more about how this networking is working. Coming down here, instructions. Okay, part 1, we're going to examine the HTTP traffic. We're going to use simulation mode. Simulation mode is a nice mode that's interesting inside a Packet Tracer. Normally when we do a lot of stuff inside a Packet Tracer, we use real time. That means everything happens like it does on a network. Well, if you think about that, everything on the network happens in milliseconds. It happens so quickly, you can't actually see each step, how it goes. Simulation mode allows you to go step by step through the exercise, and you can see how each step is working. And that's what we're going to do here inside a Packet Tracer for this exercise. So step 1A, click the simulation mode icon. Down here in the bottom right, we have real time and we have simulation. I'm going to go ahead and click on simulation mode. Notice it pops up another window here. This window, now we can see the step-by-step that's happening. But we only want to see the HTTP traffic right now. So what we're going to do is we're going to come down here, click on Edit Filters. And here we have 4 tabs. IP version 4, we want to make sure nothing is checked here. IP version 6 tab, nothing is checked here. And then on the miscellaneous tab, everything is unchecked except for the HTTP. We want to make sure that HTTP is checked and everything else is unchecked. Once that is, we can go ahead and close that, clicking on the red X. And now it's going to filter out for only HTTP activities, Hypertext Transfer Protocol, or what we commonly know as web traffic. Okay, step 2. Step 2, we're going to actually generate some web traffic so we can sit back and analyze it. Now what we're going to do is come over here on the web client. Pops up the window. I'm going to make it a little bit wider. Click on the desktop tab and then click on the web browser. If I wouldn't have made it wider, sometimes that last column's hard to see. They want you to enter in the address of www.osi.local and go ahead and click go at this point in time. Well, remember, we're in simulation mode. In simulation mode, it's event driven. And so what we're going to do is need to make things go ahead step by step. Now, in order to do that, we have to use the capture then forward button. The capture then forward button is down here. It's that little, like a play button with an arrow pointing to the right, to the line. That is this do an action, step forward. Just do one action, don't do all of them. And so what they want you to do is push that 4 times. 1, 2, 3, 4. And now notice we have 4 things here. We had an animation that happened up there. Look at the web page client browser. Did anything change? So let's go back, open that up, and it says web server. You have successfully accessed the home page for the web server. So we actually got the web page that happened. So it displayed the web page. Step 3, explore the contents of the HTTP packet. And so what we're going to do is we're going to explore what happened in step by step. Every time we clicked this event and go forward, it gave us an event in the list, and it kept track of that. And now we can look at it. So click on the first colored box in our event list underneath type. And there we are. I clicked on that, and it opened up some PDU information. A PDU is a protocol data unit, and that just simply describes a piece of information that was set. And so there's 2 tabs here, the OSI model and the outbound. When we do this and we look at different steps, there'll be an inbound, and eventually when we get all the way to the last one, there's only going to be 1 tab left there. Here in step B, so we make sure the OSI model is selected. Under the outlayers column, click 7. So I'm going to go ahead and click 7. What information is listed in the numbered steps directly below the in layers and out layers box for layer 7? So down in this area, what steps are listed? HTTP client sends an HTTP request to the browser. So that's what we're going to put down there. HTTP client sends a HTTP requests to the server. So that's what it did at layer 7. Right here for this first step here at layer 7, we sent that out. Then next question, what is the destination port value for layer 4 underneath the out layers column? So underneath layer 4 here, what is the destination port? So when we send this piece of information, it's going to port 80 on the far side. In this first step, we already know HTTP traffic is on port 80. We're going to send it out there. And so that's what we're looking for. Here is this port 80. So that value there is 80. Next question, what is the destination IP value for the layer 3 underneath the out column? Looking here at the out layers, layer 3, what is the destination IP address? Well, the first IP address here is the source address. That's where it's coming from. So that's the web client address. The destination address is where are we going? That should be the IP address of the web server we're trying to connect into. So that destination IP address is 192.168.1.254. That's where we're going. What is the information displayed at layer 2 underneath the out layers column? If we look at layer 2, the destination MAC address. That destination MAC address, these are 2 different MAC addresses here. The one that starts with 00647CA4DEE. The second MAC address is 000196A9401D. So what information is displayed at layer 2 underneath this column? So it has 2 MAC addresses. And if we look at this, it's saying down here, next hop IP address is what we're looking for. And so for the layer 2 Ethernet addresses, we're looking at the inbound and outbound MAC addresses. Step C, click the outbound PDU details tab. So that's what we're going to do is come over here, click on that tab, and then we're going to look at some of the information here. What is the common information listed under the IP address section of PDU details as compared to listed under the OSI model. So the PDU is actually what the ones and the zeros, the information is. The OSI model tab, it was the theory. Okay, this is going to connect here, this is going to connect here. The outbound PDU is actually what's happening. So if we look here, what is the same between these? Which layer is it at? Well, if we look here, we have source addresses, destination addresses. We have some preambles. Down here, we have source IP address, destination IP address. If we go back to over here, layer 3 OSI model, 192.168, 1.1, 1.254, we have that right here. Those are our information. So what we have here is your source IP and destination IP at layer 3. Next column, what is the common information listed under TCP section of the PDU details as compared to the OSI model? So on the outbound PDU, we are going to look at the TCP section. So scroll down, we find the TCP section here. We have what is the common information here. So we have some source ports and destination ports. And that's about it. Let's go look at the OSI model. Look at that. Layer 4, we have TCP source ports and destination ports. 1027, 80. Come back here, 1027 and 80. And so that's what we have there. That's matching. We have our source ports and destination ports that are the same. And that was at layer 4. Our layer 4 MAC address. Next question, what is the host listed under the HTTP section of the PDU details? So we're on the outbound PDU details tab, and we scroll down to the HTTP section here, and we're sending out a request here. Notice we can scroll up and down, and this is where we have the host listed. So that's where we're going to. So that's the first part of the question, www.osi.local. And then what layer would this information be associated with under the OSI model? Well, looking and remembering that, this domain name, the resolving of that, is done at layer 7 on the OSI model. Layer 7 of OSI. So that's where this information would be associated, at layer 7. Now working through here, clicks the next colored box underneath the event list. So we're going to click the second one down here. Only one layer here is active. Only one layer is not grayed out. That's layer 1. That's the ports. That's the Ethernet. The device is moving the frame from the buffer and placing it on the network. So it's taking it from, okay, let's do this, to actually doing it. So it's putting it there for the port to send out. Advance to the next HTTP box in the event list. So I'm going to go and click on the third one down. So we are clicked on the third item here. If we notice at the top of the PDU information window, we can see what's going on here for the OSI model. We're at the device of the web server. So we're on the web server. We got a request in from the web client. It's the destination to an HTTP client, something that will understand it. What happened here is we have this up arrow. So data is traveling up here. Data is also traveling from the in layers to the out layers. And so as it goes in here, we're going to look at something. So comparing the information displayed in the layers column with that of the out layers, what are the major differences? So when we compare these two layers back and forth, we can see that the in layers, information coming in here on our web server, it's the source it came from 1027, but it's destined for port 27 on me. But now when I send it out, that's going to go out my port 80 and destined to port 127. That's the port the web client used to request that. Then we also see that the source and destination IP addresses, they've switched. So now the request came from the client to the server, and then now we have to switch the source and destination to send the response back. That's what we're looking for. That's what is happening at this point. So what's the major differences? Source and destination ports swapped. And also the source and destination IP addresses have been swapped. And if we look at this, we've also swapped the MAC addresses. So the source and destination, once it reached the web server, had to switch again because now we're sending a response back. So that also changed at that point in time. The source and destination ports swapped. So we had all that swapping mainly because now the source and the destination, when we make the request, is one way, but now to get the response back, we have to change the source and the destination. Okay, click the inbound and outbound PDU tabs. So we can see this is what it looks like. So coming in, this is what it looked like at the Ethernet layer. This is the preamble, destination source address. We can see our MAC addresses. Notice 1.1 is on top, 1.254 is on the bottom. Then we come down here and we look at our port numbers. 127 is on the left, port 80 is on the right. As we look at that, we can see that. Click on the outbound. Outbound, that information switched around. Remember, we had 1.1 on top and 254, so now our source and destination swapped around. 1027 was on the left, but now we have port 80. Once again, source and destination swapped there. Click the last colored square under the info column. How many tabs are displayed? Well, over here, we just have two tabs. We have the OSI model and the inbound. Now, we don't have anything going out because we're getting that request in here on the client. And once again, we're at the web client here. The source is the web client, destination is the web client. So we're bringing in information. So we have the OSI model, how we go up and down it. The inbound PDU has both, or the inbound PDU has only inbound information because we are expecting that response back. So how many tabs are there? 2. Because no outbound traffic. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Part 2. We're going to look at the TCP/IP protocol suite. First part here, we looked at the HTTP and the requests that are happening. Now we're going to look at some of the TCP/IP stuff that is happening behind the scenes to make this web request work. Now we close any PDU windows, done that. In the events list filters, visible events section, click show all or none. So right down here, I'm going to click the show all / none button. So I clicked it once, now it's showing nothing, but I want it to show all, so I'm going to click it a second time. And look at that, we have a whole bunch of information. Now, remember we had our filter earlier with just the HTTP events, and we only had 4 of them. So 1, 2, 3, 4. Those were the only 4 HTTP events we had, but we have a whole bunch of other events that are happening to make this request, this web page appear on your browser. What additional events are displayed? Well, looking here, down here, the purple blue has HTTP, but we have some TCP events, we have some DNS events, we also have some ARP events. ARP is Address Resolution Protocol, taking taking MAC address and associating it to the proper place. DNS. Okay, why don't I know what ARP does? There we go. ARP finds MAC addresses. It makes a request to find where the MAC address is located, and that way it keeps track of it and knows where to send information. DNS, domain name service, associates a domain name, www.domain.com, to an IP address, because traffic travels across the internet using IP addresses, not domains. So we need to transfer that into a domain name, and that's how we do that. We also have TCP. How do we actually control that information to go across the network? We use the TCP protocol here. So what we have here is we have DNS, we have ARP, and TCP. They're different protocols. There may be some extra entries in there depending upon what happens. It could be up to 35 different protocols. Now what they want us to do is click the first DNS entry. So up here at the top, make sure you scroll all the way up. They want us to click on this DNS entry. On this DNS entry, explore the OSI model and the PDU model tabs. And so we're looking at them. Notice the request is going out, source, destination, because once again, that's where we're sending it. And it's going out on port 43, and it's a DNS query, what we're looking there for. Click on the outbound PDU. What information is listed in the name field in the DNS query section? So scroll down until we find the DNS query section. Here's the DNS query, and this is what we're looking for. This is the question they're asking. We have this domain name, www.osi.local. So I'll put that in our answer sheet right away. That information, that's what we're asking is, we have this domain name, what is the IP address? And so that's what goes in the DNS query. Click the last DNS info colored box in the event list. So click the last one. So starting at the bottom of the list, scrolling up, here's the last one. Click on it. At which device was the PDU captured? So where was this? So at the web client. So at the PC, that's where it was captured. What is the value listed next to address in the DNS answer section of the inbound PDU? So we need to find the DNS answer section. If we look for the DNS answer section, we scroll down. Here is the DNS answer section. What is the value listed next to the address? And what we need to do is look for the IP address. And that's what we're looking for. And the value is 192.168.1.254. 192.168.1.254. And if we remember correctly, that is the IP address of our web server. So the web client looked for the name www.osi.local.com to figure out what IP address it is. Came back and said the IP address is 192.168.1.254. That is assigned on our web server. Find the first HTTP event in the list and click the colored square box of the TCP event immediately following this. So find the first HTTP event, that's right here. Click on the TCP event immediately following that. Then look at layer 4 on the OSI model tab, right? Highlight layer 4 in there. In the numbered list directly below there in layers in the numbered list directly below the in layers and out layers, what is the information displayed under items 4 and 5? So here's the in layers and out layers. 4 and 5, the TCP connection was successful. The device sets the connection state to established. So it set up our TCP connection to our web server. that's what it did. So now we can actually start transferring data. And so for TCP connection successful, 5 device sets connection to established. Now, once again, we have our connection. It's there, was successful, and we've established it. Click the last TCP event, highlight layer 4 in the OSI model tab. So here's the last TCP event. Click layer 4. Examine the steps listed directly below in layers and out layers. What is the purpose of this event based on the information provided in the last item in the list? Should be item 4. So looking here, we have a TCP acknowledgement. We receive some segment information. TCP segment has expected peer sequence number, so that means that was good. And then the device sets the connection closed. So what happened is we got our information. We're all done with it. We're not expecting any more. Let's go ahead and close that. And so we close the connection. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.